Same thing, the same simplified architecture which we were discussing about yesterday. Yesterday we have seen only that persistent storage or the disk storage concept. Now, try to understand what is this is all about, external interfaces, when those interfaces comes into picture for communication purpose. So as is clearly mentioned here, external interfaces are used for communication with HANA. So only when the communication happens, further your request processing will continue. So to understand that in a better way, let me show you. So this is HANA Studio, which we are going to install later on. But what I'm doing in this HANA Studio is I'm just going to the studio. I'm opening SQL console here. In this SQL console, we can write SQL statements. I'm writing a simple SQL statement here. Some simple statement like this. I'm executing it. So here what I did is, first of all, I connected to the HANA database. And after connecting to the HANA database, I did send a request now to execute this select statement. So that was executed and the results was written here and displayed in this console itself. So basically when I am doing it, the communication is happening using this interface here called SQL interface. In such cases, database uses that SQL interface. But that's not going to be the same always. Suppose assume that in another situation they want to go for some reporting. They want to build some reports. So whenever they want to build some reports, say example, they want to use Microsoft Excel as reporting on top of HANA. So from this MS Excel, they want to connect to the HANA database. So I'm going to the Excel. There are some options here, which I'm using to connect to HANA DB. Observe here what I'm using. I'm using SAP Hana MDX provider. Because this is reporting, I'm not going to access the tables directly. I'm going to access some models, which they call them as in general terminology, cubes. So now when I'm connecting here by providing the server details like this, so connection succeeded, and further they'll proceed with their reporting. So because I don't have any, that's actually a fresh new server. That's why it's not showing any data sources there. So if they have some models, they can access those models, they can build. This is a new server just now installed. So in this situation, it won't use, the database doesn't use this SQL interface, because there the request or the communications happening from a different kind of tool. Basically we call them as WLAP reporting tools. All they communicate with HANA database using that MDX. As you observed there, that MDX only I used HANA MDX provider. MDX means multi-dimensional expression. So for WLAP reporting or multi-dimensional reporting, they use that MDX interfaces. Okay, so in the case of reporting tools, that MDX interface, it's not all reporting tools I'm saying. Some of the reporting tools as I shown you, just like MS Excel. And there is also a possibility of doing some activities through browser, because HANA is having a facility where we can develop applications and run applications within HANA, and those applications, we can access them through browser. Say example, in fact, as an administrator, we are going to use some of them. I'll just show you one. So I'm just going to the browser. So let that server start. We'll just try to access some tool. It can be HANA Cockpit, which is web-based. It can be some lifecycle management. It can be there is something called Web ID, what SAP is offering. All these are accessible through browser. Okay, started here. Now, see from here I'm connecting to the database. In the browser I'm connecting to the database. So I need to grant some additional privileges there. So which I'm granting now. See, that user now is authorized to do some of these activities from development activities. So from here he can send the request and perform those activities. See, this is called web-based development workbench editor. So when the requests are sent from here, from the browser, so obviously we can't use these SQL and MDX interfaces because they don't understand the request what we are sending. The request what we send from the browsers are HTTP request. They're not understandable to this. That's why they're given a separate web interfaces here. So basically meaning of that is to deal with the request, the connectivity is coming from different tools or different interfaces there. SAP is internally, HANA database is having all these different external interfaces, the communication purpose. So once that happens, they connect to the database, and then they can start sending the request. Okay, I want this information. I want some table information. I want have some a view executed and get the reports. So what actually system does whenever connectivity happens, as a given their user ID password along with the host name and instance numbers, first and foremost thing it will do is it will create one session. The session management will take care of it. So every connectivity, every logon will have a session. So that we can also call it as a user session. So whatever that user is performing there, all the activities will be performed within that session only. So once he connects to the database, a session will be created. Within the session, he'll perform different transactions. Transactions can be anything. So what is a transaction? Transaction is basically a collection of commands. It's a collection of commands which will be executed together. So you can say transaction is atomic. When I say transaction is atomic meaning of that is either the transaction is successful or failed. It's not like within the transaction one command is successful, another command failed. Nothing happens like that. That's why we call it as transaction is atomic. So that's where we have the session management, transaction manager. And whenever he's performing a transaction, as I told you, transaction is nothing but collection of commands. Those commands need to be executed. So whenever that command need to be executed, first and foremost thing database does is it won't execute the commands directly. Before that, first it will verify whether the user who is sending this, who is trying to perform these activities, authorized to perform it or not. So that's why we have authorization manager also. And they're requesting for any metadata like any information about the views. Just now I tried something from MS Excel. So actually there, if views are available, those views need to be displayed there so that they can select the views and do the reporting. So views displaying means it has to give information about the views that will be taken care by this metadata manager. So once system verifies that that user is authorized to execute those commands, and then those commands will be further sent for request processing to this request processing and execution control. Anything you try to perform in the database will be with SQL. So whenever it comes to executing that SQL commands, uh, first optimization will be done. There will be SQL optimizers. So what these optimizers does is before executing the statement, first of all, they prepare a plan, execution plan, what we call it as. Means what is the optimum way of executing this statement or the command. So that plan will be prepared. It may look simple, but it's one of the most complicated thing. Execution plans are very complex actually. So it will identify the optimum way of executing that command or a statement. So whatever the plan it's preparing to execute that statement, that will be stored in a memory, in buffer, and that we call it as SQL plan cache. The reason why that plan is stored in that SQL plan cache is, suppose next time you're trying to execute the same statement, instead of preparing that execution plan again, it can get the execution plan from the plan cache, which saves some processing time. That way we can improve the performances. That's why they also keep those execution plans in the plan cache. And then once plan is prepared, according to the plan, further execution will be taken care by the respective engines. So if you observe here, basically in HANA database, there are two types of tables. We have row store tables and column store tables. Row store tables and column store tables. Generally in traditional RDBMS, you find only row store tables, but here we also have this column store tables concept. So because of that, on top of these, they're given some special processing engines. So those processing engines will be responsible for executing your statements according to that execution plan. Actually, they will be assigned to, there will be a processor. If you see the physical one, processor will have multiple cores. Those cores will execute your commands there as per that execution plan. So when we say these engines will be responsible for executing the statements according to the plan, but if you observe carefully, on top of row store, they're given only one engine called row store engine. Whereas on top of column store, they're given multiple engines here. There is something called join engine, VLAP engine, and calculation engine. Three different types of engines are given. So what is the difference? Why we have these special engines on top of column store? Why they are not there on top of row store? See, to understand that, to understand the significance of those specialized engines, so what you need to understand is actually need to recollect some information which I discussed earlier. If you remember when I explained you about doing reporting on top of HANA, I clearly told you that they never do reporting on the tables. Even I shown you in one of the company landscape also, if you recollect that. So first of all, the tables from the source systems will be replicated into HANA database using some ETL tools or replication technologies. Once the tables are replicated successfully into the HANA database, they don't do reporting on those tables. Instead of that, first they build the models. In general, we call them as cubes. In general warehousing terminology. So they build those cubes, and then on top of those models only they go for reporting. The reason also I explained you. The reason why they build models or the cubes is if you do reporting on the tables directly, that becomes only two-dimensional. Whereas the customer will always looking for multi-dimensional analysis, multi-dimensional reporting they want to do. So if they want to go for multi-dimensional analysis, so there's no way they can do it if they do it directly on the tables. That's why they build those models like cubes. On top of those models, they go for reporting. So as HANA is a database, as we try to build models in the database itself, we don't have any application on top of that. So in databases, we don't have any concept called cubes. So you know that clearly, you know what kind of database objects we come across. We don't have any concept called cubes in databases. So that's why to implement these data models in SAP HANA, in the place of those cubes, they came up with something called information views. Remember this term, HANA information views. Don't call them as views because terminology is so very, very important for you. Okay, so we call them as information views, only information views. Don't use any other terms. Okay, because that's a special type of objects they've introduced, modeling objects in HANA. So they are similar to the cubes. I'm not saying exactly, similar to the cubes, almost the same kind of functionality you can achieve. So on top of that, you can build reports. So when we say on top of the tables, first they create these information views, then based on the information views, they go for reporting. Those information views, what we create or what they create as modeling consultants will be like this. You observe here, if you just observe, there will be different types of information views. So there are mainly three types of information views: attribute views, analytic views, calculation views. Remember this. For three different analysis requirements, there may be small to complex requirements. So for different analysis requirements, are given basically three types of information views: attribute views, analytic views, and calculation views. And moreover, these views are created based on those tables. So they'll create some views, something like this. These are all views only. You observe this they call it as multi-dimensional model. So like this, they build the views. This is a modeling consultant responsibility. So they'll take care of it like this. Okay, so for different analysis requirements, different views they create, three types of views: attribute views, analytic views, and calculation views. So then we go for reporting on top of that. So when someone does reporting on top of this, those views need to be processed. So where they are going to be processed? So to process those three different type of views, they given, you can observe here, three different types of engines. Join engine is the one which is responsible for executing those attribute views or processing those attribute views. OLAP engine is the one which is responsible for processing of the analytic views. And calculation engine is the one which is responsible for processing those calculation views. So three types of views they are given. For processing, three types of engines they are given. Now here comes the doubt, why they are given only on top of these column store tables only? There is a reason. Column store tables, the specialties, column store tables will give you always a high read performance. I'll show you how it looks like. So column store tables will give always high read performance. So when you compare with row store tables. So obviously, see, when we say whatever these models they are building, these information views they are creating, ultimately they are going to use these information views for what? Analysis, reporting. So analysis is all about performance of reading the data. So if you want to have a better performance for your reporting, you have to create those views or the models based on these column store tables. In fact, SAP made it mandatory. So what SAP has done is to make these analytics more effective. SAP made it mandatory for all the people to create these views, information views, only based on column store tables. Row store tables are not allowed at all. So whatever the tables you see here, whatever the tables they used in these models, any model you see, these are all tables. So these tables, if you go and see the definition of the table, see this type here, it's a column store table, right? So any table like this, these are all column store tables. So SAP made it mandatory to create these information views only based on the column store tables. And that's the reason why they given these three specialized engines on the column store. Row store is just only row store engine because normal commands only will execute, but there is no concept of creating information views on top of row store. That's why we don't have those on top of row store. So that's the difference. That's the speciality in that. Okay, so remember this fact that these three engines on top of column store are meant for processing three types of information views they create: attribute views, analytic views, and calculation views, which will be created by modeling consultants. Yeah, that's what you find in this request processing and execution control. And this is a place relational engines where the data will be stored in the memory. And this portion, already we discussed about that yesterday. So to have a better understanding of what is speciality in column store tables, how they will be useful for you. When we say it improves the read performance, not just about read performance, they will be very, very useful mainly to compress the data, more data compression is possible with that. How is it so? So how it is different from row store? So to know about that, have a look at this. To keep it simple, this diagram you just try to understand. Whatever you find in the middle there, that's a data set. You consider that as a table. Whatever the storage is, whether the table is a row store table or column store table, that's the way you see the data. That's the way you see the data. Irrespective of whether it is a row store or column store, the way it's presented to you is going to be the same. That doesn't change. Then what is the difference between row store and column store? So basically it's about storage, how the data is stored in the database, in the memory. You see on the left hand side, the data is stored row wise here. This is first record, and then this is second record, then this is third record, this is fourth record. So data is stored row wise, row 1, row 2, row 3, row 4, like that. But on the right hand side, if you observe the column store, data is stored column wise. First country column data, then you have person, then you have quantity. Here data is stored column wise. Now to understand how the read process is different in these two, take a small example. I'm writing a select query now. I'm writing a select statement like this: select country from this table. Whatever the table is, select country from the table. So when you say select country column from the table, if it's a row store table, imagine how the data is read by the system. Now first row country column value here, it will read this France. and then second row is here somewhere, and then third row is here, and fourth row value is here. Means basically it has to read the data from different memory locations. From one read to next read there is a gap. Technically they call it as cache misses. If you have more cache misses, time taken will be more. Obviously performance will be low. That's what happens in the row store. But when it comes to column store, if same select statement, if you write select country from the table, so it reads the data from continuous memory location. See here, the entire country column data we have in one single place. So continuous memory locations, it will read the data, which will take very, very less time. And that gives a drastic improvement in the performances. So that's the biggest difference what you can find. Okay, so that's one point to remember. That's why when you write select statement with okay, you want to choose selected columns, always column stores will give a better performance for you. But don't do this mistake, never do this mistake of writing select star on the column store tables. You know, generally you write that select star. Star means what? Replacement for all the columns. Means you're trying to read all the columns of the table. So when you write that select star from the table name, you're reading all the columns of the table. So when you read all the columns of the table, this is the better one actually. Row store will give a better performance compared to column store. Never do that mistake. And it's a proven fact that only less than 10% of the database columns are used for analysis. That's why these column store tables will be very, very effective for you as far as reading the data and presenting the data is concerned. And moreover, they've designed these column store tables in such a way that the data will be compressed by removing all the duplicates. So they've written here compression, then removes all the duplicates. So to understand that, you might be knowing that dictionary concept. So what it does here is, you see this is the country column. So country column, there are a lot of duplicates here. Denmark is repeated, France is repeated, or maybe Italy is repeated. But first of all, it will maintain a dictionary. This is a dictionary. Belgium is represented with 1, Denmark with 2, France is 3, Italy 4, like this. So basically those character values as an alias they have, replacement is integer, some integer. So row 1 is showing, see this 3 means row 1 is having France, row 2 4, that is Italy. So it will refer to that actually. Row 4 we have Denmark, or maybe row 4 we have 4 Italy, row 5 we have Denmark, like that. So this integer data is even more compressible. First of all, you know, United States of America you want to store. If there are 1 million customer, 1 million times you need to repeat it. 1 million times you need to repeat that United States of America. Obviously, you know, space occupation will be more. And moreover, character data we can't compress so much. So that is replaced with integer value. So first of all, storage of the storage space will be less here. And another thing, integer data is more compressible. That's the advantage you have. And they even maintain that inverted indexes also. So Belgium, which row we have, Denmark, in which rows, 5 and 6. And then you have France, in which row, then the fourth one, Italy, in which rows. Italy is there in second row, fourth row, eighth row. Inverted indexes also. So whenever that particular record you are reading, it can read and present the data for you. So these kind of mechanisms they follow there. That's the reason why. So it's not just about high read performances. You'll get high data compression factors also, because they have to balance this. It's not just about one way. I mean, you need to always think about the cost factors also, which plays a vital role when we are providing solutions for the customers, because customers definitely always will be concerned about that. What they're concerned about mainly, if you know these facts, a customer is always concerned about only two things. He's always concerned about something called TCO, total cost of ownership. Another one is called ROI, return on investment. So TCO must be as less as possible. ROI should be as high as possible. So that's what always they'll think about and look at. So in that context, that's very, very important to check on the cost factors also. Another advantage you'll be having is as you're storing the data column wise here, parallel processing, we can do it very, very effectively. So one processor core can work on one column, same time parallelly another processor core can work on another column. See, two different columns. Core 1 is processing this, core 2 is processing this. Even we can do partitions. One partition can be processed by one core, another partition can be processed by another core. That's what we call it as parallel processing, which is very, very important in SAP Hana kind of solutions, because that also drastically improves the performance as well. These are all the benefits what you find with the column store. That's why all the application tables will go with the column store tables, whereas system tables, the core system tables will be row store tables. A lot of system tables will be there, which are needed for operating your database. All that will be row store tables. So how do they manage, basically, when they go with the column store, how do they manage read and write operations? See, the problem is if you want to have high data compression, you need to compromise on the write process, because you want to write the data into highly compressed. Already there is some data which is highly compressed. You want to write into that directly. It definitely affects your write performances. So then how do you balance that? Because see, there is some data which is compressed 7-8 times. You're trying to write the data into that. One more record you're adding, again it has to add that record and recompress the data once again. So obviously it's time taking process. It will affect your transactions. So how did they manage that? That's also an important point we need to understand. Generally, if you keep one single memory, only one single memory for your database table, then it becomes a very big issue. So to avoid that, yesterday I've shown you the definition of these tables and runtime information. So here we can see that, so basically there are two types of storages they are using for a table. Any column store table will have two storages. One they call it as main storage or main memory. Second one is called delta storage or delta memory. Main and delta. So if the table is accessed, it will be showing you here. So this table is not accessed in this particular system. Let us try this one. This is already accessed, so obviously we should give. This one is also no one has access till now. So we can load and check that if you want. I'm loading into memory. Now we can see some main memory consumption now what we have, and delta memory, what is the estimated maximum memory consumption showing there. So main memory you can see always is bigger in size, delta is smaller, very smaller. So what they do here is to handle and balance this read-write operations performances. So they use that concept of main memory and delta memory. See, main memory, if you are speaking about, it's highly compressed actually, very compressed, highly compressed. You can see compression rate is very high. It's read optimized. It will have sorted dictionary and it is read optimized, this one, main memory. So they never try to write the data into this main memory, never. Because writing into highly compressed data is too slow. Since then it needs to be recompressed after each write. So that's why they never try to write the data directly into this main memory. Instead of that, they're doing write operations only into the delta memory, which is write optimized. See how they're balancing it. So the column store divides each column into two parts, delta and main. Every column will have delta memory and main memory. So this enables a high compression as well as high write performances at the same time. So suppose Already data is there here. I am writing new records into this. Then whenever the data reading happens, it will read the data from main memory and delta memory, merge the data, and it will present the data to you. It will read from both because it has to, because all the new records will be available in delta. So delta should not grow. If it drastically grows, what happens is performance goes down, because, and moreover, space occupation will be more, because delta memory compression rate is basic, it's very little, and we don't have any sorted dictionary there. So that's why regular intervals, what happens is this delta memory will be merged into main memory, that they call it as delta merge. So that's taken care by the system itself automatically. If the delta merge happens regularly, so it will keep on merging this into the main at regular intervals, so that it will keep this delta always right optimized, so that read optimization will be done for this main memory. But anyhow, it will read the data from both these memories. But if delta drastically grows, read operations definitely will affect it. Users will start complaining that easily we can find out. So generally, one of the troubleshooting activities we are going to do is this. Generally, when end user complains about, okay, till now it's working fine, for the last few days we are having performance issues, particularly one specific report which is developed on particular table, we can go and verify what is the size of the delta. For any reasons, if that merge is not happening, we can execute the delta merge manually. All those, when we are going for monitoring and troubleshooting, we can look at. And another thing which people need to understand here is how they do the updation. Suppose there is already a record in this main memory, you are trying to do an updation. Means you are trying to directly do something in this main memory, but we are saying that main memory, no write operations at all. No writing at all. So even for updation also, actually they use a different concept here. Even you write update statement, it will act as insert statement only. And technically, they use that word upsert. Upsert, update plus insert, upsert, they call it as. So actually it will insert a record into this. Whenever someone is trying to read the data, so it will read the data from main memory, delta memory, merge the data. So whenever the same record it come across in both these memories, whatever the latest record we have, only that latest record will be presented. The new value will be presented there by merging them. That's how it happens. So there's no direct update concept at all here. I call it as upsert. So these all mechanisms they have implemented internally, because of which we are experiencing all the things. We are experiencing the high compression rates, as well as we are experiencing high read performances also same time, that they are able to balance. Write operations also plays an important role. That's why we can use the same HANA database same time, both for OLTP as well as OLAP. Both we can. That's a specialty we have. Okay. So these are some of these basic things what you need to understand about the basic core architecture, which we can call it as simplified architecture. Okay, I'll just show you this database. This is our HANA DB. So once we start working with this, and when we go for that advanced stages of where monitoring and troubleshooting discussions, so we'll be looking at these things in detail. Like here we can find, as I told you, there will be sessions, whatever the sessions created, what is running, what is idle, what operations taking place in this particular session, all that we can find out. So These are all going on there, threads for processing of your request. So by chance, due to any lock mechanisms, any transaction is blocked, that we can find in case if any is there. And as I mentioned that whenever the plans are prepared, execution plans, what we call them as, those plans will be stored in this plan cache. These are all plans. So as I mentioned, for a statement which you are executing, for us it may look very easy. I mean, it looks so easy. But actually the plans, if you see, they will be very, very complex. If you visualize the plans, what is that? Operation with the same idea. Okay, let us check. See this plan? Statement looks maybe very simple, but if you see the plans, so much is happening internally. So we have that flexibilities, we have options to visualize those plans and all that. So all that SAP is providing to you. So graphical way of accessing it. Okay, this is the latest version 2.0. This one is SPS 12. The memories and all that we can see. Here also we can find same information. Sessions, threads, what is going on. Plan caches. Okay, so that's all what we have in that simplified architecture concept. So it's pretty easy thing. There will be other concepts as I mentioned. I told you already yesterday itself. There will be some service level architectures. Means there will be different types of services available in HANA database. When we do an installation and then after installation, we are going to look at it. We'll be knowing then what kind of services you have and the significance of each and every service, what exactly that service is doing. In fact, at that time you'll understand that this is architecture. What you are seeing is architecture of one single service, which is the main service, and that service architecture only they name it as a simplified architecture. All other services are just small activities, nothing much they do, but this is the major one. That's why this they'll generally consider as a HANA architecture, HANA database architecture. So in the Dropbox, you should find these documents also. These presentations also I placed there. You can refer to those presentations also there. Clearly. Okay, so tell me any doubts you have. So next we are going to get into this one, sizing. So we'll be having almost 1.5 session only discussion on sizing part itself. Yeah, Ravi, I told you many times, frame this questions properly. HANA prefers row store column. There is no concept of preferring. HANA is having two capabilities. Within HANA database, you can have a row store table or column store table. So whenever you create table, whenever you replicate table, you have to decide whether your table is going to be row store or column store. HANA won't decide that. You have to decide. If I want, I can create my table as a row store table. I can create my table as a column store table. Whichever I want, I can do it. Hmm? So I prefer to go with column store only because column store will give all that flexibility for me. Or flexibility or whatever I explained, all that compression, high data compressions will be there, better readability, right optimization is there. I prefer that. That's why any application, when they install, all application tables will be column store tables. Any table I am replicating will be a column store table. HANA won't decide that. Any more queries? Start reading. Look at those documents. Start reading right now. Architectures we are already into. Start preparing yourself. Just a matter of 3 sessions we'll be getting into the practicals. We'll start installations. You have to start practicing more there at that time.